Alright, so we didn't have a 2.3G because that was just graphing linear functions, and I don't think we need to worry about that. We can all graph a line. And so we're taking a look at 2.3H, determining symmetry. And let's take a look at the several types of symmetry, and then we're going to discuss the symmetry of the graph. So looking at this parabola, first of all, let me go ahead and write what that function is. Here's the function, x squared. Now, let's take a look at some of the characteristics of this function based on the fact that it's to the second power. If I put in a particular x value, let's say I put in a 2, I'm going to get out a 4. But if I put in a negative version of that x, I'm still going to get out a 4. The fact that that's x squared means that no matter what value I put in for x, whether I put in a positive or negative value of x, I'm going to get the same y value. So if you think about that, here's what we're doing. We're saying over a particular x, up a particular y, over the same x this way, I'm going to have the same y this way. Well, that for some reason just kind of reminds me of a butterfly. In other words, I'm looking at, if I can get that erased, I can't. I'm looking at something like this. Like if we had a butterfly, I don't know how to draw a butterfly very well, but what we have is we have symmetry through the center, right? We have a symmetry through the center. And that's the same thing we have on a parabola. These parabolas, or the butterfly type functions, are actually called even functions, and they're even because if I put in a positive x value, I get out a positive y. If I put in the negative x value, I still get out the same positive y. And so you can also take a look at the exponent and see that that's an even number that the variable is carrying. The variable has an even exponent. Well, that is the reason that we get a positive value. It will not let me it won't spit out a negative value for me. I can't get one. And so we call those even functions. And in addition to even, when we want to discuss the symmetry, we actually talk about how is it related to the overall coordinate plane. Well, the symmetry is about a line, and it's symmetric about the y-axis. So symmetric about the y-axis. So we call this type of graph y-axis, we say that it has y-axis symmetry. Okay, so it folds in the y-axis, and that's called an even function. Okay, so let's take a look then at, as you can imagine, an odd function. So here's an odd function. This is called odd. And of course there can be functions that are neither, but an odd function, let's go ahead and write what this one is. This is f of x is equal to x to the third power. Well, you're looking at that and immediately you're probably realizing, oh, well that's because it's odd because it's raised to an odd power. And you're right. The reason that this right here has to do with the symmetry is this. If I put in let's say I put in a 2 into this function. Put in a 2. Let's go ahead and make a table of values and let you see it. If I put in a 2, I'm going to get out an 8. I put in a 2, I get out an 8. If I put in a negative 2, though, this time, I put in a negative 2, I'm going to get out a negative 8. So putting in a negative 2 is not going to give me the same y value. It's going to give me the opposite y value. Well, when I do that, that's putting in a negative 2, then going down negative 8, I'm going to get something, and this reminds me not of a butterfly, but of a windmill. Because I have a windmill effect, it's going around in a circle, and it's what we call point symmetry, not line symmetry. So it's point symmetry, and it means this, that if I go 180 degrees, that's not 180 degrees on that picture there, but basically we're saying that if I can rotate that around the origin 180 degrees, then it has origin symmetry. We call this origin symmetry. And it's point symmetry, not line symmetry. So we say that's origin symmetry because it's rotating around the origin. And if I actually do rotate this green thing, it would land on itself 180 degrees later. It would actually print the same picture. It wouldn't create a new picture. Okay, so that's odd and origin. Now you can think about this. That's easy to remember, right? Odd, origin. So now you might be asking yourself, well, what if I had something like this? A function like this. What if I had, it doesn't matter what the coefficient is, by the way, 3x to the third plus 2x squared minus 1x plus 8, whatever. Okay, well, if I look at all of the exponents here, the exponents that are the powers, right? The variable that's raised to the power. If I look at all of them, I have a mixed bag. I have odd, even, okay, odd, even, and so this one would be neither. Because it's not going to give me this situation, right, like a butterfly. It's not going to give me this situation like a windmill. So it's going to be neither. And so that's what we have when you have that type of situation. And one last situation that you might come across would be this. What about absolute value? Because, Ms. Savelle, absolute value doesn't have a power with it. Well, if you think about it, absolute value acts like what? It acts like, in other words, what it does to the input. It acts like a square. Okay? It acts like squaring. And so, in other words, it's kind of like an x squared in that it doesn't allow a negative to come out. And so this right here we consider an even function. If there's not, of course, a plus x to the first power, right? That would be a neither. So this is an even function. It has y-axis symmetry. All right, hope this was helpful. Thanks for watching.